Each of the 25 balls in a certain box is either red, blue, or white, and has a number from 1 to 10 painted on it. If one ball is to be selected at random from the box, what is the probability that the ball selected will either be white or have an even number painted on it? Statement 1. The probability that the ball will be both white and have an even number painted on it is 0. Statement 2. The probability that the ball will be white minus the probability that the ball will have an even number painted on it is 0.2. Now, looking at this, we're told each of the 25 balls in a certain box is red, blue, or white and has a number painted on it. So we're selecting one ball at random from the box. So we want the probability that the ball will be either white or have an even number painted on it. So the probability that the ball will be white or even is going to be defined as, according to our standard probability calculations, probability of white plus probability of even minus the probability of both, or white and even. So what we need to know is we need to know the probability of white alone, the probability of even alone, and the probability of white and even if we're going to be able to tell what the probability is that the ball will be white or even. We need all of these pieces of information. So statement 1 tells us the probability that the ball will both be white and have an even number painted on it is 0. So that gives us probability of white and even. But it does not give us anything about probability of white or probability of even alone. So that is going to be insufficient. The next one, statement 2, the probability that the ball will be white minus the probability that the ball will have an even number. So probability of white minus the probability of even is 0.2. Now, this tells us nothing about the probability that it's white and even at the same time, so that's insufficient. Now, if I put 1 and 2 together, we're going to get the probability of white minus the probability of even plus the probability of white and even. So that's 0 and that's 0.2. So notice that this is not the same as to say probability of white plus probability of even minus probability of white and even. Even if we flip the signs, you get this minus probability of white plus probability of even minus probability of white and even. So there's actually no way that we're going to be able to get this statement, probability of white plus probability of even minus probability of white and even, from the information provided. So we can say that even together, they're insufficient. So the answer is E.